Hello viewers, in today's lecture we are going to take up some problems which are based on logarithmic differentiation. In logarithmic differentiation we make use of the properties of logarithms. So let us start. Here we have to find the derivative of this function. Y is equal to x plus 1 over x raised to x plus x raised to 1 plus 1 over x, right? So here we will assume that this function is equal to, say, u, right? U is equal to x plus 1 over x raised to x, and v is equal to x raised to 1 plus 1 over x. Now this function y becomes u plus v, right? Now we have to find the derivative of y with respect to x. So therefore what we will do, we'll find dy over dx is equal to du over dx plus dv over dx. Now our aim is to find du over dx from this function and dv over dx from this function. So let us first find du over dx. So here's from this function, if we take the log of both sides, so what we'll get, we have log u is equal to a log of x plus 1 over x raised to x. Now here we'll make use of one property of log, that is, if log of m raised to n, then it is n log m, right? So here log of x plus 1 over x raised to x becomes x log x plus 1 over x, right? So this is log of u. Now we differentiate both sides with respect to x. So the derivative of log u is 1 over u, and by chain rule we have du over dx, right? Now this is equal to this is the product of two functions, so we'll apply the product rule for derivative of two functions. So here we have x multiplied, the derivative of log x plus 1 over x is 1 over x plus 1 over x, and then we have to differentiate this function, and the derivative is 1 plus 1 minus 1 over x square, right? The derivative of x is 1 and the derivative of 1 over x is minus 1 over x square, plus then we have log of x plus 1 over x, and the derivative of x is 1. Clear? Now here's if we simplify this expression, we have 1 over u, this is du over dx is equal to, this is x square plus 1, and x we can write x times this is x square plus 1, and this x will go to the numerator. So we have here x square plus 1, and then here we'll have x square minus 1 divided by x square plus log of x plus 1 over x, right? So 1 over u du over dx can be written as this x, and this x square get cancelled, and we are left with x square minus 1 divided by x square plus 1 plus log of x plus 1 over x. And if we take u to this side, then we have du over dx is equal to u times x square minus 1 divided by x square plus 1 plus log x plus 1 over x, right? So this is this du by dx is equal to this expression. So let us call it 1, right? Okay. Now viewers, let us find the derivative of v with respect to x. So let us take v is equal to x raised to 1 plus 1 over x. Now we'll again make use of the logarithms. So we'll take the log of both sides. So log of v is equal to log of x raised to 1 plus 1 over x. Now log v can be written as, again we'll apply this property to this expression. So 1 plus 1 over x will come to the front. So 1 plus 1 over x is times log of x. Now differentiating both sides, we get the derivative of v, log v is 1 over v. Then we have dv over dx is equal to, this is the product of two functions. So we'll have 1 plus 1 over x. The derivative of log x is 1 over x plus log x. Then derivative of 1 plus 1 over x is 0 because the derivative of 1 is 0 and 1 over x is minus 1 over x square. So if we simplify it, we get this is x plus 1 over x times 1 over x, and this is minus 1 over x square log of x, right? So this can be written as 1 over v dv over dx, and this is x square, and taking x square common, so we have 1 over x square as common, and we have x plus 1 minus log x, right? If we take v to this side, then we have dv over dx is equal to v times 1 over x square x plus 1 minus log x, right? So now viewers, we have to find the derivative of dy and derivative dy over dx. So we have obtained du over dx and we have obtained dv over dx. Now we'll substitute these values in this equation number say 1. So dy over dx is equal to du over dx can be written as u. For u we can write this expression. So we have x plus 1 over x raised to x, and then we have x square minus 1 x square plus 1 plus log of x plus 1 over x. Clear? So for du over dx we have written this expression, then plus dv over dx. So we'll write this one. So for v we'll write this expression. So this is x raised to 1 plus 1 over x times 1 over x square, and then we have x plus 1 minus log x, right? So here's this is the required derivative of y with respect to x. Clear? Viewers, now let us take this example. Find the derivative of f of x is equal to 1 plus x multiplied 1 plus x square multiplied 1 plus x raised to 4 multiplied 1 plus x raised to 8, and hence find f prime of 1. So here we have to do two things. First we have to find the derivative of this function, that is we have to find f prime of x. So we'll make use of the concept of logarithmic differentiation. So if we take the log of both sides, then we'll get Now take logarithm of both sides. So we have log of f of x. So this can be written as log of 1 plus x, 1 plus x square, 1 plus x raised to 4 times 1 plus x raised to 8. Right? Now here we'll make use of the property if we have to find the log of m times n times p, then this can be written as log m plus log n plus log p, right? So here we have log of 1 plus x, this is m, this is n, this is p, and say this is q, right? This is m, this is n, this is p, say this is q. Now this is plus log 1 plus x square plus log 1 plus x raised to 4 plus log 1 plus x raised to 8. Now if we differentiate both sides with respect to x, we have 1 over fx and then we have f prime of x. Clear? Always remember the derivative of log fx is 1 over fx because the derivative of log x is 1 over x, and then by chain rule we differentiate f prime of fx, which is f prime of x. So here the derivative is 1 over 1 plus x, and if we differentiate 1 plus x we get 0 plus 1, right? Plus the derivative of log 1 plus x square is 1 over 1 plus x square times the derivative of 1 is 0 plus the derivative of x square is 2x, plus the derivative of log 1 plus x raised to 4 is 1 over 1 plus x raised to 4, then the derivative of 1 is 0 plus the derivative of x raised to 4 is 4x cube, right? Plus the derivative of log 1 plus x raised to 8 is 1 over 1 plus x raised to 8 times 0, the derivative of 1 is 0 plus x raised to 8, the derivative is 8x raised to 7, right? Okay, so here's we can write it, we can simplify it as 1 over 1 plus x, then we have 2x divided by 1 plus x square, then we have 4x cube over 1 plus x raised to 4, plus we have 8x raised to 7 divided by 1 plus x raised to 8. Okay, now this is f prime of x divided by fx. Clear? Now we take this fx to this side, so we have f prime of x is equal to f of x times 1 over 1 plus x plus 2x divided by 1 plus x square plus 4x cube divided by 1 plus x raised to 4 plus 8x raised to 7 divided by 1 plus x raised to 8. So this is the required derivative of this function. For fx we can again substitute this value. Clear? So we can write f prime of x is equal to, for fx we write this expression, so we have 1 plus x, 1 plus x square, 1 plus x4, then we have 1 plus x raised to 8 times this function, that is 1 over 1 plus x plus 2x divided by 1 plus x square plus 4x cube divided by 1 plus x raised to 4 plus 8x raised to 7 divided by 1 plus x raised to 8. Clear? So this is the required derivative of this function. Clear? Now viewers, we have to find the value of f prime of 1. So what we will do, we will find the value of the derivative at x equal to 1. So f prime of 1 means we have to find the value of dy over dx or d by dx of fx at x equal to 1, right? So let us assume this function as y. So what we will do, we'll substitute x equal to 1 in this expression, right? So what we will get, so f prime of 1 is equal to, if we substitute 1 here, so we get 1 plus 1, that is 2. Then 1 plus 1 square is 1, so we have 1 plus 1 is 2. Then we have 1 plus 1 raised to 4 is 1, so 1 plus 1 again 2. Then we have 1 plus 1 raised to 8, it is again 1 plus 1, that is 2, right? So here we have 1 over 1 plus 1 is 2. Again this is 2 times 1 is 2, and 1 plus 1 is square is 2, plus 4 times 1 cube is 4, and 1 plus 1 raised to 4 is again 2. Then we have 8 times 1 raised to 7 is 8. Then we have 1 plus 1 raised to 8 is 2. Clear? Now we will solve this expression. This is 2 to the 4 to the 8 to the 16 times, and if we take the LCM here, then we have 1 plus 2 plus 4 plus 8, right? And this is 16 times 8 plus 4, 12 plus 3, 15 over 2. And this is 2 8s are, this is 8 15s are 120. So this is the value of f prime of 1, right? Now viewers, let us take this problem. Here we have to differentiate sin x minus cos x raised to sin x minus cos x, where pi by 4 is less than x and x is less than 3 pi by 4. So here again we'll make use of the concept of logarithms. So let y equal to sin x minus cos x raised to sin x minus cos x. So taking log of both sides, so we have a log of y is equal to log of sin x minus cos x raised to sin x minus cos x. Now we'll take here log m raised to n. This is equal to n log m. So we'll make use of this property, right? Log m raised to n is equal to n log m. So log y is equal to log of sin x minus cos x raised to sin x minus cos x. So this is m, this is n. So log y is equal to sin x minus cos x times log of sin x minus cos x. Clear? Now we'll differentiate both sides. So differentiating both sides with respect to x, we have 1 over y, here we have dy over dx, and then we have here the product of two functions. So we'll take sin x minus cos x as first function. So sin x minus cos x times derivative of this function. So the derivative of log sin x minus cos x is 1 over sin x minus cos x. Then by chain rule, the derivative of sin x is cos x, and the derivative of cos x is minus sin x. So this is plus sin x, right? And then plus, then we have the second function log of sin x minus cos x times the derivative of sin x minus cos x, which is cos x plus sin x, right? Okay, so here we have 1 over y dy over dx, and here this term and this term get cancelled, so we have cos x plus sin x, and plus cos x, we'll write cos x plus sin x in front of log, so we have cos x plus sin x times log of sin x minus cos x. So if we take sin x plus cos x as common, if we take these two terms, then cos x plus sin x will take common, so we have 1 plus log of this is sin x minus cos x, and if we take y to this side, so we have dy over dx is y times cos x plus sin x times 1 plus log sin x minus cos x. Clear? Again, if we resubstitute the value here, so y is sin x minus cos x raised to sin x minus cos x times cos x plus sin x times 1 plus log of sin x minus cos x, right? So here's this is the required derivative of y with respect to x. Clear? Now here's, let us take this problem. Here we have to differentiate 5x raised to 3 cos 2x. Now let us take y is equal to 5x raised to 3 cos 2x. Now taking the log of both sides, we have log of y is equal to log of 5x raised to 3 cos 2x. Here we have to use the property log m raised to n is n log m, right? So log y is equal to 3 cos 2x log 5x, right? So 3 cos 2x is equal to, say, n, and 5x is equal to m. Now differentiating both sides with respect to x, so we have 1 over y, and this is dy over dx, and here we have 3 and cos 2x and log 5x. This is the product of two functions, so what we will do, we'll apply the product rule, which says that d by dx of u times v is equal to u times derivative of v, then v times derivative of x, u, right? So here let us take this function as u and this function as v. So we have cos 2x times derivative of log 5x, which is 1 over 5x times 5, because the derivative of 5x is 5, the derivative of x is 1. Clear? Plus then we have log of 5x times derivative of cos 2x is minus of 2 sin 2x, right? Okay, so therefore dy over dx can be written as 3 times of y. We take this y to this side, and here we have 5 and 5 get cancelled, so we have 2 cos 2x over x, and minus 2 sin 2x log 5x, right? Now substituting the value of y, here we have 3 times 5x raised to 3 cos 2x multiplied cos 2x over x minus 2 sin 2x log 5x. Clear? So this is the required derivative of this function with respect to x. Viewers, let us take this problem, and here we have to differentiate a raised to x with respect to x, where a is a positive constant. So let y is equal to a raised to x. So we have to find dy over dx, and a is a positive constant. So taking log of both sides, we have log y is equal to log of a raised to x. So log y is equal to x log a, right? Differentiating both sides with respect to x. So the derivative of log y is 1 over y, and then we have dy over dx. And log a is a constant, and the derivative of x is 1. So we have 1 times log of a, which is equal to log a, right? So therefore dy over dx is y times log of a. And if we substitute the value of y, so we have a raised to x times log a. So viewers, always remember that the derivative of a raised to x, where a is a positive constant, is a raised to x times log a, right? Suppose we take a is equal to 3, then the derivative of 3 raised to x is 3 raised to x times log of 3. Similarly, if we have a is equal to say 7, then the derivative of 7 raised to x is 7 raised to x times log of 7, right? And viewers, if we take a is equal to e, which is the exponential function, then the derivative of e raised to x is equal to e raised to x, because here we are substituting e for a. So we have e raised to x times log of e, and log of e is equal to 1. So therefore this is e raised to x times 1, that is equal to e raised to x. So this is the famous derivative of exponential function which is equal to itself, right? So the derivative of e raised to x is e raised to x.